This is Bob Capetta from the University of Illinois at Chicago, and this lesson is on the disk method. The best metaphor that I have for the disk method is how cold cuts, when they're all put together, form the original solid. So if we think of this as our solid, we can decompose it into a collection of disks. So if we think of started with this, and this is the result. The volume of the solid is the sum of the volume of all the disks. Each disk is a mini cylinder. It looks like a circle and it has thickness. So we're going to find the circles, we're going to find the thickness, we're going to figure out the volume of each slice of bologna, then add those together to find the volume of the entire solid. That's the metaphor we're going to be working with. So our first example is we're given a region R bounded by the x-axis on the bottom, the y-axis on the left, f of x equals 2x plus 1 on top, and the line x equals 2. We want to find the volume of the solid obtained by revolving this region about the x-axis. So we can see this, 2x plus 1 from 0 to 2. So this corner point is what, 2, 5? Corner point 0, 1. If we rotate this thing around the x-axis, can you visualize what that looks like? It's actually a frustum, or maybe you think of it as a Christmas tree stand of sorts, but the whole thing is solid. We want to visualize what that surface of revolution is going to look like. So I've got a graph here. Here is 2x plus 1, and I want to revolve it around the x-axis. Let's go ahead and do that. See what it looks like. And that gives us a solid of revolution. Now again, it is a solid. It is not hollow. The way that it looked on the computer, it appeared as if it was empty on the inside, but indeed that's solid. So if we were going to slice this on a meat slicer starting on this end, the cold cuts would be very small, and as we're moving over and over and over and over, the cold cuts get larger and larger and larger. And we're going to think of one piece of this, one slice of bologna in the middle of this. We're going to find its volume and then use that to find the volume of the entire solid. So again, here's y equals 2x plus 1, and here is a piece of bologna, half of it. We're looking at it sideways. So if I take this rectangle and wrap it around the x-axis, it will make a disk. We want to find the volume of that disk. So let's go through that process. Again, there's the equation y equals 2x plus 1. And the change in x is the thickness of this rectangle. So the area of a circle is pi times the radius squared. So we're thinking of this disk. This is half of it. So the radius is the distance from the axis of rotation up to the function. The radius here will be 2x plus 1. So we have the area of the circle is pi times 2x plus 1 squared. But a piece of bologna has thickness. If we want volume, the volume of that disk is the area of the circle times the thickness. Change in x is the thickness of that piece of bologna. So the volume of the disk is pi times 2x plus 1 squared times the change in x of this one piece of bologna. Now we have several pieces. In fact, if you look at these little rectangles built into this, we could imagine many, many pieces of bologna being used. So the entire solid is the sum of all of the other disks. So we've got the sum of pi times 2x1 plus 1 squared times delta x. But the volume, as we shrink delta x to 0, will be defined by an integral. Integral from 0 to 2 of this, and then delta x becomes dx. So shrinking delta x to 0, we get the volume of the solid to be the integral from 0 to 2 of pi times 2x plus 1 squared dx. Let's quickly do that integral. There is the integral. 2x plus 1 times 2x plus 1, 4x squared plus 4x plus 1. 4x cubed over 3, 4x squared over 2, also known as 2x squared. Integral of 1 is just x, as x ranges from 0 to 2. Plugging in 2, 4 times 2 cubed over 3 plus 2 times 2 squared plus 2. Plugging in 0, 4 times 0 cubed over 3 plus 2 times 0 squared plus 0. Of course, this whole piece becomes 0. 8 for 32 thirds, 428 to 32 thirds plus 10 times pi, and we get 62 pi over 3 is the volume of the solid that we're given. All right, let's take a look at another example. This time we have a region R is bounded below by the x-axis and above by the function f of x is 4x minus x squared. We want to find the volume of the solid obtained by revolving this region about the x-axis. So if we revolve this, what does it look like? It looks a little bit like a Spanish onion, and if we would slice it on a meat slicer, each one of these things would be a disc. We're going to add up the volumes of all those discs to get the volume of the solid. So try to visualize that onion. So the bottom half is here. We're going to first, by focusing on this rectangle, rotating that thing around the x-axis, it will give us a disc. We want to find the volume of that disc, of that piece of bologna. Our function up there is y equals 4x minus x squared, and the thickness of that is delta x. This will be the radius of that piece of bologna. Area of the circle is pi times the radius squared. The radius is 4x minus x squared, so the area of the circle is pi times 4x minus x squared squared. Volume of the disk, area of the circle times the thickness of that piece of bologna is delta x. But that's just one piece of bologna. We have several pieces that we're going to add together to make up that Spanish onion looking thing. So the volume of the solid is the sum of pi times 4x minus x squared squared times delta x. Then we shrink delta x to 0, and we get the integral from 0 to 4 of 4x minus x squared squared dx. And let's quickly do that integral. So starting with this, 4x times 4x is 16x squared. 4x times negative x squared is negative 4x cubed, and another negative 4x cubed. And then negative x squared times negative x squared is positive x to the 4th. This is what we're integrating. So we're going to do that this way. 16x cubed over 3 minus 8x to the 4th over 4 plus x to the 5th over 5, evaluated as x goes from 0 to 4. And then 8 over 4 is just 2, so simplifying that a little bit, 16 thirds x cubed minus 2x to the 4th plus x to the 5th over 5 as x goes from 0 to 4. Plug in 4, plug in 0. Again, the nice thing, this goes away. 16 times 4 cubed over 3 minus 2 times 4 to the 4th plus 4 to the 5th over 5. Probably need a calculator to compute that. I've done it here for you. Pi times 1024 thirds minus 512 plus 1024 fifths, which turns out to be 512 pi over 15. And we have one more question. A region R is bounded by the y-axis on the left. The function y equals x squared plus 3 on the right, and the line y equals 7. So this is our region of interest. And this time we're going to revolve that about the y-axis. So that thing is going to look like a bowl of some sort out this way. So here's our graph. We're going to rotate that thing around the y-axis. Can you visualize that? What will that look like? There we go. Now the difference is we're going to take the meat slicer this way. We're going to cut the pieces this way. Circles, smaller circles to larger circles as we go up. So our radius will be an x value rather than a y value. So here's the relevant picture. There's our graph. It's rotated around the y-axis. There's our radius as our cold cuts are stacking up this way. Our function is y equals x squared plus 3. Our thickness here is change in y, and our radius is the x value. So what we need to do is we need to solve this for x to find out what that radius is going to be. Well, y is x squared plus 3. Y minus 3 is x squared, so the square root of y minus 3 is x. That will be our radius. We know the area of a circle is pi r squared. We know our radius is root y minus 3. This will actually be an easy integral to do. So there's the root y minus 3. That is our radius. Area of the circle is pi r squared. Area of the circle is pi times root y minus 3 squared. Volume of the disk is the area of the circle times the thickness. So can you see a cold cut here, a piece of bologna here? Its thickness is change in y. So the volume of the disk is the area of the circle times the change in y. We want to stack a whole bunch of these. Again, looking at all these little rectangles, you could imagine each one of those is a piece of bologna, and the volume of the solid is the sum of all those pieces of bologna. And then as we shrink delta y to 0, that becomes an integral. From what to what? What does y range from? Remember, we're going to have a dy integral. Lowest y value we see is 3. Highest y value we see is 7. So we've got the integral from 3 to 7 of pi times y minus 3 dy. Again, a relatively easy integral for us to do. So there it is. Pull out the pi, antiderivative of y minus 3, y squared over 2 minus 3y. Plugging in as y goes from 3 to 7. Pi times 7 squared over 2 minus 3 times 7 minus 3 squared over 2 minus 3 times 3. 49 halves minus 21 minus 9 halves minus 9. Pi times 7 halves minus negative 9 halves. 7 halves minus negative 9 halves, of course, is 16 halves, or 8 pi. And that will conclude this lesson.